Okay guys, this is the second video that you really need to watch, which is going to be, well, technically the third video. Video 1A and B was going to be the one that goes over pages 9 through 11. This is video 2, which goes over pages 15 through 16. So you need your packets. This again is on page 15 to 16. I'm going to ask that you start working on the warm-up A and B. And then when you're done, A, B, C, and D. And when you're done, because I'm crunched for time, you can check these answers. So check answers on Google. Okay, what you would do is you would type this in, 2008 AP FRQ Form B, and look for this question, and then you'll be able to find your answers. If there's not all the answers for it, we can upload the notes on Friday or go over it on Friday in class. You'll let me know. But again, check answers on Google. Take about 10 to 15 minutes to answer that one, and then watch the rest of the video. Let's keep going. But pause and try those problems first. A, B, C, and D. Okay, if we have several variables in a problem that all changes as time progresses, then we actually have a relationship between several functions of time. What we're going to look at today, in short, is we're going to look at taking the derivative with respect to time. So, what we mean by that is it looks like I'm going to have, let's see here, hold on just a second. Here it is. So given this equation, we are now going to take the derivative of our variables with respect to time and plug stuff in. Historically, students usually like this one. So let's see if you guys think the same way. Let's go and take the derivative with respect to time on both sides. On both sides. Okay. So the derivative of the left is going to be dy, because I took the derivative of y with respect to time. I could do 1 times dy dt, but that's just dy dt. Equals the derivative of x, the root x, is going to be 1/2 x to the negative 1/2, just like usual, times the derivative of x with respect to time. And now it says when x is 4 and dx dt is 3, we can solve for dy dt. So let's do it. When x is 4, I have 1/2 root 4 times dx dt is 3. So let's see what that gets us. It gets us 1/4 times 3 equals 3/4. So dy dt is equal to 3/4. So for this function, if we're talking about time, the rate that y is changing at is 3/4 when x is changing at 3 units per whatever. Okay, example 2 of 3. So now we have dy dt. Again, we're looking for dy dt. When x is 3, y is 4, and dx dt is equal to 8. Okay, so let's see here. Let's take the derivative here with respect to time again. Respect to t. Okay, 2x will be my derivative of x squared, but I took the derivative of x with respect to time. Plus, I'm taking the derivative of y squared, which is always 2y, but I took the derivative of y with respect to time, and the derivative of 25 is 0. Now I just got to plug everything in. So x is 3, so I'm going to do 6 times dx dt, which is 8, plus 2 times 4, which is 8 times dy dt, and that's equal to 0. If I move everything over to one side of the equation, I get x dy dt is equal to -6. And for example 3 of 3, I have a point is moving along the graph of the function like a spider. She told this funny story. You should ask her this. It's funny. Such that dx dt is equal to 2. If y equals sine x, find dy dt when x equals pi/6, when x equals pi/4, and when x equals pi/3. Let's do it. So taking the derivative of both sides with respect to time, I get dy dt on the left side equals, and see, notice Leibniz notation is going to help here. That's all. The derivative of sine x is going to be cosine of x, but I got to take the derivative of the inside for chain rule, and the derivative of x is dx dt. And now we have a few values that we have to find. When x equals pi/6, dy dt is equal to cosine of pi/6, which is cosine of pi/6 is equal to √3/2. And in this problem, dx dt is always equal to 2, so that's just √3. Okay. When I have x equals pi over 4, dy dt is equal to, okay, cosine of pi over 4 is root 2 over 2. It's 2, which is just root 2. All right. And then when I have something like pi over 3, that means dy dt is equal to cosine of pi over 3, which is 1/2 times 2, which is just 1. That's it. Taking the derivative with respect to time, not too shabby. Hopefully you guys did okay with this. And again, please excuses for yourself. Good luck on the work. Thank you for watching.